Today, we will see how impossible to hack blockchain network. Let's look at a demo to demonstrate how hacking is not possible. Let's look at a demo on block. A block consisting of three parts, namely a block number, nonce, and data. This all together it's provided a hash. Here, to check whether this block is valid or not, by seeing a hash value, we can tell that whether the block is valid or not. Here it starts with the four zeros and followed by a set of strings, which means it's a valid. And this is a green color is the second point. Suppose if it's an empty data, now I'm trying to type some data called an hi, it's converted green to red color, which means this block is not valid. And even though it's not valid, it will provide an hash which are different, which doesn't having a four zeros at the beginning. So to how to validate this block means you have to do an hashing algorithm using a proof of work, and which will be going to generate and 40 followed by a set of string. Now I'm clicking a mine button. It will take a processing of certain time and it will going to give a valid block. Now this red color it's converted to a red green, which means this block is a valid, which having a block number as 1 and data high, and the nonce is 102270, having a hash of 40 followed by set of string called as a valid block. Now see, if I change this nonce as some 10, this hash is going to change. If I type an 100 block number 1 and the data high, provide a hash of this one, and which is not valid because this is not having a four zeros at the beginning followed by the string. Now if I type and one more 100, then it will provide a hash, but it will not a valid block. And then how to get a valid block? Now just click on the mine button. It will going to apply an algorithm called proof of work, and it will convert the red color into green once that mining is done. This process is doing by an miners. Then what is a blockchain? A blockchain is a set of blocks like a block 1, block 2, block 3, block 4 and block 5 having a same block number, nonce and data having a hash, and the previous hash will help to traverse back to the previous block. An advantage of previous hash is that you can trace back of its origin. Now let's look at here. We have 5 blocks. Now I want trying to modify the block 5. The data is empty. Now I'm typing in hello here. Then it's converted green to red, which means this block is not valid. In block number 5, it's converted green to red, which means we done some modification here. The data has changed, that's why the hash also changes. So here we can observe that one, the hash of this block is started with B13, which means this is not valid because of it doesn't meet the condition of 4 zeros followed by sets of strings. So to validate this block, just click on mine. Then it will take a certain time to validate, to convert into valid block. Once converted, it's converted into the red to green. You can observe now. Now, if I want to go the previous block of block 4 with the help of previous hash, here we have hash of 4 zeros followed by AE8. This hash is linked to block 4. So using this hash, I can easily to traverse a back. So this is one advantage in the blockchain. So once you move from end of the block, you can go at the beginning by using the previous hash. Now I am moving to the block 4. The hash of this one is 4 zeros AE8. So which I can traverse from block 5 to block 4 with help of previous hash. And same thing, I can traverse block 3 with the help of previous hash is 40B9. The block 3 hash is 4 zeros B9. So right now I am in the block 3. Example, now assume that I am the hacker. Just I want to hack this one, block 3. When I doing a hacking of this block 3, now see that the color of block 3, block 4, block 5 also changes from green to red, which means something is happening here. So how to identify that one? Now see the hash of this block 3 is, it start with C915, means it doesn't meet the condition of 4 zeros followed by set of strings, means this has been done some modification. So now observe that if I do the mining here, the block 3 is going to convert into red to green. It doesn't have a conversion of remaining link called block 4, block 5, because you can observe here also the hash is not meeting, and if you see the hash of block 5 also not meeting, it's different. So you have to do again a mining for block 4 to validate, and block 5 also you have to validate. So once it's done from red to green, then you are getting a tick button to mine. So this is a way of whenever any attacker is done an attacking of a one node, he can do the changes. But in a distributed network, there are n number of nodes are connected. So if I want to hack any node, then I can only modify only one node. But in a distributed network, we have to do all the nodes. Here you can observe that while I doing the mining, how much time it's taking. So it's a time taking process. It's take a lot of power consumption, and we require high internet speed to meet the target. Let's look at, in a distributed network, we have three peers, namely peer A, peer B, peer C, which means the replication of all the data of peer A having the same data in the peer B also, and peer C also. Look at in the peer A of first node is hash of 401578. Now look at peer B first block is 401578, which means same. Peer C also you observe 401578. It's also same. Now what we'll do, you can see that all the hashes or sequence of no blocks having the same hashes. The hash of block 5 is 40E4, and peer B hash of block 5 is also 40E4. Now peer C block 5 also having a hash of 40E4, which means all the network which is connected in a peer-to-peer distributed, all the ledger will be updated same data available in a network. Now look at, if an intruder in a peer A, he got to modify block 3. Okay, now observe that I want to hack this one, hack data. So you clearly we can observe that one, the color is going to change from green to red. Then that block 4 also changes, block 5 also changes. Now see that here the peer B is not changes because he hacked only one node. So before that, if I want to validate this one, just I want to click the mine to convert to get the valid string. Then after block 4, then after block 4 is mine and get the successful validation, then I want to go for the block 5. Okay, in the block 5 also I want to do it done the same thing. Now look at the hash of block 3. The block 3 hash is 40EF273. Okay, in a peer A. In a peer A, the hash of block 3 is 40EFP. Now look at a hash of peer B. Block 2 hash is 4012FA. Here we have 406FN273, which means it is not at all having a same values. Now look at the peer C also, block 2 4012FA, which means here the block A is attacked by something. He was hacked by something. So which means this peer will not consider. So you see observe that if I done a modification in a distributed network, I have only one node it taking a lot of time to mine. In a distributed node ledger, it have a lakhs of nodes. It's a very impossible to do hacking in a blockchain, because if I want to hack, I want to identify how many nodes are connected in a network. I want to do the modification for all the nodes, then it's a possible to hack. But in this scenario it's not possible, because it's impossible to identify the anonymous network. Now let's look at the token based. In token base, it contains transaction like $25 transferred Darius to Bingley, Elizabeth to Jane as a $4.27. Like that one, we have a transactions in a block here. And if I see the block B, it has some set of transaction. So here in example, which having a 5 blocks with different transaction. Now I'm going to down in PRP also having a same set of transactions, because it's an connection connected in a peer-to-peer network, which all the replicated of data having same. If I want to try to modify this value to some $100, then you can see that it changes from green to pink, which means I done some modification. And you can see the hash of this block is not meeting the condition of 4 zeros followed by set of strings, means this PLC is hacked. In Coinbase, which helps that how to go the origin of the amount. Let's see, we got a Darcy transfer $25 to Bingley, but we don't know how the Darcy $25 is received. This is a small disadvantage in the token base. Let's we look at the Coinbase to understand exact what is an origin of coin. In Coinbase transaction, we can cross verify that how that Andres is got and $100. So let's take an example. Andres got $100 by the company, paid a salary to him. Now Andres have 100 unspent dollars. Now in the second block, he spent $10 to Sophia, $20 to Lucas, $15 to Emily, and one more $15 for Madison. Totally he done $60 which are spent, and he have remaining 40 unspent dollars. Like that one, Sophia receives $10 from Andres. Emily got $15 from Andres. Like that one, can you see in the block 3? Again, Emily transferred Jackson as a $10. So we can trace by its origin. Like, suppose example, here we can see that Jackson transferred Alexander of $2. So we can trace back it how the Jackson got $2 by with help of previous hashing. We can traverse to the block 4, and we see that Jackson received receives from Sophie of $8. That's why he spent $2. So here is one more advantage of Coinbase is that in blockchain we can go back and trace it how we got the amount. So any percent amount we can trace by hashing of previous in a block. In peer-to-peer network, the benefit of blockchain is by tracing the backing and knowing how did he receive money. Using this network, we can avoid black money transaction. Using the blockchain, lot of advantages has been providing, like tracing the transaction origin. It's impossible to hack, avoiding black money transaction, paying taxes to government, and many more. So that's it. So from this demo, you can understand that how the tracing is happening and how the block is hacked by intruder. Then we can know that whether the block is an hacked or not. So this is a impossible way to hack the block in a blockchain. Thank you.